Hey everyone, can you hear me okay? Yeah. Perfect. I'll be talking about Vue and AI search. I'm Daniel Piri, and you can find me anywhere online as Malgamviz. I'm really used to looking to my side and seeing my slides, so this is a bit trippy. Anyway, I do developer experience at Weaviate. I'm a writer, developer, artist, as you heard, plant dad, and oversharer. So you'll be getting some themes there. I want to start out by saying something. This talk is about search, right? Everything we do on the internet is about search. I don't think we can question that. We look for songs, we search for movies, we do Wikipedia. It's all about search. But search isn't just in the way we access the internet, right? I had this thought, and it came to me, search is more about discovery. We try and discover things. We look for specific items. And so, to my oversharing, I really like coffee. However, I have a very complicated relationship with coffee. I do not take caffeine, which I've found in this city is very hard to find decaf coffee. No one likes that for some reason. And I can't take cow's milk, which is, it makes that experience really interesting. And so anyway, I walk to my coffee shop and I ask for coffee with chocolate in it, right? And my barista knows coffee with chocolate, this is something that is probably not on the menu, because your menu looks something like this. And it's not on the menu, but they know that's a mocha. And so they give me a mocha. And so in this small interaction, there's an element of discovery. And I'm going to relate this to search. So stay with me. So I ask for something, I make a request, and then the person in the shop sees if they can serve that request, right? And so when I tell them I want coffee with chocolate in it, there's a search that happens. They need to see if this is something that they have available in order to serve this request that I'm making. And this is something humans have developed over time. It's very, very intuitive for us to make that connection, coffee, chocolate, mocha. If that's something you know, it's very intuitive. However, this isn't the same thing for machines. If my barista was a machine, they would look at this menu and be like, coffee with chocolate, not on the menu, sorry. Really awkward interaction. And this is how a lot of our search experiences work. But not just in the applications we use, it's in the applications we build, right? Have you ever had this experience where you're in your site search, you're in your internal search, and you know what you're looking for, but you just don't know the keyword that you need to find it, right? And so you keep typing so many different things and you don't get it, you type something else, you don't get it, and it's just a terrible experience. And I think this is something that we can all relate to. And we really take for granted the idea of search. Just to sort of go on from, it's really bad, right? Google really changed the way we search. It made it so easy to find stuff on the internet in a way that wasn't, I will type this specific thing out and I will find it. And for a long time, this sort of capability was locked away behind a lot of proprietary software in a lot of big companies. Only they had access to this incredible experience with search. And this is what I like about AI search, particularly. It democratizes access to all these incredible experiences. And you could build a sort of Google. We'll try and do that in this talk. So let's democratize search with AI. How does that sound? Thank you. Okay, so what is the problem here with search, right? Search works, but only sometimes. We aren't really happy with the results we get. And this is because of a lot of search is powered by something called keyword search. And so the way keyword search works is you type something in and it does a keyword match and you get something back. An example being, I would like to know how airplanes or why airplanes fly. I think this is a very valid question. These are huge metal things in the sky. You want to know. And so you have a database of a bunch of articles, Wikipedia posts, and I search, why do airplanes fly? And this is the response I get. Why you should fly with expensive airlines. And according to keyword search, with the keyword match, this is a valid response, right? Because it's relevant to the item that I put in, but it isn't relevant to the question that I asked. The problem with keyword search is it doesn't capture the context of human-like interactions, because a lot of our interactions are human-like, right? We want to know why a plane flies. We want to discover this item and add to our knowledge. And it's just a really terrible experience for your users because one, you don't get a response to your question, and two, your users just end up really frustrated. And so to combat this, I want to introduce something called semantic search. And so this is the AI portion of the search. And semantic search captures the content, or the context rather, of your search term, and then gives you the most valid response. So in a semantic search world, when I type, "Why do airplanes fly?" I get this article called The Dynamics of Flight, and it talks about how an airplane's wing shape lets it be in the sky, right? And I wouldn't be surprised, having just seen this very basic example of keyword search, semantic search, if this is probably you. You want to switch, you want to change, you really want this more human-like experience. But how does this work? How do we actually capture the meaning? Spoilers, it's machine learning models. So if you aren't very familiar with machine learning models, particularly embedding models, I think a couple of speakers have talked about embedding models. These are models that encapsulate the meaning of information that you put into them. And so the numbers that you see there on your right, the numbers that you see there on your right are embeddings. And so this is an array of numbers that represent information that you put in. And these machine learning models are specifically trained to encapsulate information from real world data. And this isn't a foreign concept. Capturing meaning with numbers is something I think everyone is familiar with. An example is the RGB scale for numbers, right? We use RGB, red, green, and blue, to describe what a number looks like. And so red, for example, is 255, 0, 0. That is red. So on a scale of 0 to 255, where 0 is no red and 255 is red as hell, that is red, right? And emerald is what you see there. And so this concept, like I mentioned, is not foreign. We do the same thing with vector embeddings. And so we have specific machine learning models that are trained to encapsulate information of specific types of data. And so you could use something like Hugging Face or Cohere, Mistral AI, OpenAI, Ollama, or Gemini, which I'll be demoing today. I'll be demoing OpenAI and Gemini. And the idea here is you get your information. And so in this example that I gave, we have these two search terms, right? Or these two results, rather. Fly with expensive airlines. We put that into a machine learning model and we generate vector embeddings. And again, these embeddings encapsulate the information in this text. And we do the same thing for our other article. So we get that article, we put it into our machine learning model, and we get those vector embeddings. The next step is really important. So once we have those embeddings, we have to put them somewhere, right? We put them in what we call a vector space. And this is just a 3D representation of what a bunch of different vectors stored in this space would look like. You have all of these items dotted around. This is three-dimensional. I think one speaker mentioned most embedding models have from hundreds to tens of thousands of dimensions, right? And these dimensions could be like, is this an educational article? Is this in English? Is this in X, Y, and Z? And so all these items describe this data that you put in. And so once we have these items in the space, we can then search through them. But before I show you or tell you how, I'll give you an example. So we have a bunch of items here that you see. And so once these vector embeddings are in a space, you kind of start to see patterns. Things that are similar get grouped to each other, because when you sort of point towards one item, you look around it, you sort of have items that are similar. So we have fruits here, apple, banana, close to each other. We have cat, dog, wolf, all close to each other. And so we leverage this behavior of a vector space to do semantic search. And so back to our example, why do airplanes fly? What happens in the background when we make this search? We pass that query into our embedding model, and then we, as you might have guessed, get vector embeddings. We then put those vector embeddings in our vector space, and then we look at what's around us. Because from what we've said, we understand that anything close to what I put, or anything close to this search term, is relevant to what I asked. And so what we get returned in our case is the NASA article, right? And this is just one response. We could get a bunch of different responses around this item. And all of this is powered by Weaviate. In our case, I'll be actually showing you how to do this, how to build this semantic search application. And so I'm a big fan of Nuxt.js. I'll be showing you a demo of how I built a vector search application with Nuxt.js and Weaviate. Weaviate being the database that stores these embeddings. It was made specifically to query, retrieve, and store these embeddings. And it's what powers our semantic search. Right, so I have this application that I built, which is semantic search with Weaviate. I have a database of the Rolling Stones top 500 songs of the century. I don't know if anyone's a music fan. And the way this application works at the moment is I will type something in, like hello, and it puts that out on my screen, right? This is the way it works right now. What we'll do is make this a semantic search application. And so go along with me. So I'll just go into my VS Code. Oop, wrong one. Okay, so this mirrors what our application looks like. This is a Nuxt application. I'll just zoom in so it's a bit more visible. And so just mirroring what you saw. We have a cover, we have a search component, we have something to handle loading, and then we display the results that we get. We also have a function that calls an API route called search, and we pass whatever the user inputs into that route, and we make a search. So ideally, when we want to build out this vector search functionality, we want to be in the search.ts. And so if we go to search.ts, this is where the magic will happen. We import the Weaviate client. We have a TypeScript client that we built. We do some validation, and then we make a connection to our cloud service. So I'm using Weaviate Cloud Services. If you don't want to use that, Weaviate is open source, and you could store your embeddings and keep them to yourself and not have these be on someone else's cloud. And then really importantly, I talked about embedding models. I passed an API, an OpenAI API key here, because I'm using OpenAI's embedding model to create vector embeddings that I then store in my database. And then at the bottom here, I just validate this query. And right now, what happens is I'm returning the search term that was entered. I'll get rid of this as we build out our vector search. And so in our vector search function here, what we want to do is, one, create a connection or initialize a variable that connects to our collection. A collection in Weaviate is essentially a table in a SQL sort of database. And so we'll start by saying my collection. We'll call this my collection is equal to client dot collection dot. We'll say get. My collection is called Calvin Harris. I will not explain why. And once we have this variable that helps us use and interact with our collection, we can actually make the vector search. I'll have my response here and await a query. My collection dot query, and we'll do a near text search. And that's only because we want to take text as input as we get and make our search. The first parameter here is always the query, so I'll pass the search term. And like most databases, you can limit what you get out. And then I'll just return the response and get the objects from the response. Then we actually call this function, so vector search, and pass the search term that we get validated. And then let's actually display our results. So I'll go into index.view. As you might have seen, I'm just displaying whatever we get back. I want this to actually look pretty. And so I'll comment this out and comment that out and save. Let's actually make a search. And so back to our application, things should and will change. And so we'll start out pretty simple here. Let's do songs. I want to see if there's any songs about color, right? And this is really interesting. We didn't type these specific colors, but you can see in our results, we have songs that mention color because it understands that our query wants songs that mention color. And so when we do that search, we get returned items that have color in them. We could do something similar. We could say songs about, I like this search, songs about infidelity. Not that I like infidelity. But the idea here is, this is a very abstract query, but it gets the context of what I'm searching, and it returns things that are valid towards that, which I think is extremely interesting. I could do songs about cowboys. I don't know if these are relevant. Or songs about New Orleans. And so this is a very interesting result. Mississippi is not New Orleans, right? But this is a great result because it explains how this works. It looks around it and passes the most relevant items, right? And so what we could do is we could also filter by distance in that vector space and say, if anything is larger than this specific distance, omit it from the response. And so we don't want to see that. And so there's a lot of tweaking that you can do with this search. And this is just like a very rudimentary build. This is vector search in what is 8 lines of code, which I think is incredible. But we can extend this, right? We have this vector search that gets the context of our queries and then gives us the most relevant results. We can extend this and help our applications interact with large language models. And so when I change this to generate, I can add prompts to my searches. And so I get the responses from my searches and pass those to a large language model. I'll type a single prompt here and ask for a fun fact. Fun fact. Give me a fun fact about specific songs. I want title by the artist, because these are items that come in our response. And so we just put these in our query. And I'll put please, just so I'm polite. And so let's actually make a query. We'll go back here. Let's do songs about love, for example. Or there's one search I really like, actually. When I type Beyonce, it takes some time because it talks to the LLM. But you see Jay-Z show up because it understands that Jay-Z is related to Beyonce, right? They're married, for anyone who doesn't know. But I think this is interesting. And I just remembered I forgot to actually put the response from the LLM in the application. So let's do that really quickly. We'll go into our search results and we'll just quickly do like a p tag. So item dot generated. So these are the items that get generated by the LLM. Oh, could you imagine? I forgot how to do view at a VueCon. Right. So here we go. Fun facts about songs about Beyonce, and this is like really, really interesting. But we could. Thank you. Thanks. we could extend this. This is sort of like every result that we get back, we talk to the LLM. We could get everything that we get back and be like, what could you do with this, right? And so one thing I like to test is like, these LLMs, do they have any sort of personality? And so I like to ask them what their favorite songs are. And so let's do exactly that. And so get rid of our single prompt, and we'll do a grouped task. And we'll say, what song do you not like? And why? And save that. And just because of the shape of the response, I have to change some of these things. We'll go to results, and I'll add something here. I think this is a good place to, let's do a quick p tag, and we'll say search results dot generated, and then we'll just add objects here. Okay, very quickly. That shouldn't show up. Let's do the Beyonce. What should I search for? Rivers, maybe. Let's see if Mississippi comes up. So I personally do not like the song Take Me to the River by Al Green. I find the repetitive chorus and melody to be a bit monotonous. But we get the idea, right? We get these responses, we have this semantic search, we pass this to an LLM. It really makes these really interesting experiences in our applications. And in not that many lines of code. And just sort of to extend this, I think one big part that I mentioned was importing data plays a huge role in how we interact and do this search, right? We need to create these vector embeddings. But what does that relationship look like as we go about doing that, right? How does this work? And so this is what that looks like. You have your objects, you have your data in whatever form they may be. You do an API call to your vector database and pass these objects to the vector database. Once you have these objects there, your database then sends them to a machine learning model. In our case, I'm using OpenAI's embedding model. And what that does is it sends me back these embeddings. Sorry. And once I have these embeddings, I can do the search that I just demoed. And so to interact and have this work like that, you have to create a collection to start with. You have to have a table in your database and define a vectorizing model, right? You define a vectorizer. You then choose and define a collection to interact with. So I just created this collection that I have that variable name for. And then after I do that, I can then insert sort of any information or any data that I want to import. And so this is what importing data looks like. Once you have that data in the database, you can then actually do a query. And so back to why do airplanes fly? I'm a user, I put that in my application. Why do airplanes fly? I pass that to my database. It passes that to the model. I get the embeddings for this query. And then my vector database looks at the most relevant items in that vector space, in that collection, and then sends those results to me. In this case, it's the NASA article, right? And this is extremely interesting. But you really don't have to be limited to text, right? Like I mentioned, a big part of AI search is democratizing access to everything that these big tech companies are doing, right? We have access to these models, and I will show you how. I think it's been a really interesting week for AI specifically. There have been a lot of really cool models that have come out and been released, one particularly being the Gemini one. And so I built this application, which I'll show you, and this is just me foreshadowing. But back to text, right? We don't have to be limited to text. The way we interact with applications, the applications that we build also aren't limited to just text. We have so much video, we have so much audio, and it's really hard to search through this information outside of the usual looking at the metadata and doing a lot of parsing. And so we already understand the idea of you have your text, you put that through a machine learning model, and you get your vector embeddings, right? You can then use these embeddings to search. So going on that line, we could expand that to, hey, let's do this with images. So you can get images, put them in a machine learning model, in this case, a vectorizer that encodes these images and creates the vector embeddings, and you get those vector embeddings. The same thing happens with video. put them in the machine learning model, you get your vector embeddings. And what that enables is you have all these items that have their information encapsulated, stored in this vector space, and then you can run search. So I could type and get results of video. And so I could enter lions roaming the savannah in my application and get responses that are relevant in text, image, and video. And even beyond that, I could input images as search and get image, video, or text responses. And let's look at how that works, right? So again, me oversharing. I take pictures of literally everything, and I have way too many images in my camera. And one of my favorite features of a named phone brand is I can search, right? Like I have so many pictures of my bike, but they're scattered all over. And then I just search bike and I get pictures of my bike, which is incredible. I have so many pictures of cars that I take and they're scrambled all over. As you can see, I have a bunch of images here. Like I'm just scrolling so many images, right? How do I make this experience better? And so in this application, I could search cars. And it won't work because I'm about to do something very bad. Sorry. I forgot to pass an API key. Screw it. Okay. This is very bad. Never do this. But please also don't use my API key. Ah! Oh my gosh, that was really bad. Never do that. Oh wow. We should blur that. Okay, we have our application running again. And so I'll refresh this. And now when I actually do type cars, I have cars. Thank you. But it's super specific, right? I have cars, but what if I want white cars? And all this is vector search. And I could go beyond this and say beach. Beach pictures. And you have all of these images. And like I mentioned, it sends the closest items to it in the database. So at some point, the items aren't relevant, and we can cut those out. And so we'll just go back into our application here. And I have this here. And so what I could say is I could limit this by distance and say anything that is beyond, what does this accept? Number. So we could say 2.1 or like 1.3. And let's see how that changes the application behavior. And so you could tweak details like this, right? I could also say food. And this is the any-to-any search that I was talking about. But we don't have to be text to sort of different modalities. I could upload images, and I have a data set of a bunch of images, big set, image. Right, so this is a car. Cars. And we could do more. We have a bird by the beach. And so these embedding models understand these images. Oh, this is the bottom. So you see, we have these birds. And then beyond that, we start to get things that aren't relevant. And I'll just do one more, just to, let's see, flower, like maybe this. Let's see what we get back. Right? We get the beach. And this is what I mean by it democratizes access to things that were usually only accessible to these larger, huge companies with budgets to train these models. Now everything is sort of open and you can build these search experiences. And so now it's practically your move. What will you build? What will you do? If you found any of this useful, I have resources to the demo apps that I demoed. If you want to try any of these out, all of them are built in Vue.js and Nuxt specifically. And yeah, let me know what you think. If you've got any questions, find me after. Thank you very much. Oh wait, I forgot. I'm also doing a series of like JavaScript focused webinars. So if you're interested in actually building stuff like this, you could register. And yeah, now for real, that's it.